Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have h divided by h is equals to h, and we solve this problem for all the values of h. So here first we find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards here in the first method. We move the term from denominator to the right hand side, and you see here this is h, and when we move it into the right hand side, it is multiplied by this h, and it will be written as h multiplied by h. And now further in the next step we have h is equals to h times h becomes here h square. And now in the next step we move this h from left hand side to the right hand side, and it will be written as h square minus h is equals to 0. And now you see here both of these two terms involve h, so that we will be take common h from here, and when we take common h we get the remaining values are from here we get h minus from here we get 1, and this whole equation is equals to 0. And now in the next step we divide this equation into the two cases. The first case is we write h is equals to 0, and the second case is we write h minus 1 equals to 0. So this is the first root of the given equation, and now here for the other roots, here we move this minus 1 to the right hand side, and we obtain the second root of the given equation is h equals to 1. And now you see here from first method we get these are the two roots of the given equation. And now in the next step we need to verify that is these roots be the solution, or is these roots be the extraneous root. So for verification of these roots, we need to copy down given question statement. Here it is h divided by h is equals to h. And now in this side, we will be verify h is equals to 0. And in this side, we will be verify h is equals to 1. So here, first we verify h is equals to 0. So for this, we substitute h equals to 0 on both of the sides of the given equation. After substituting this to the given equation, it will be written as 0 divided by 0 is equals to 0. And now here in the next step we have this is 0 divided by 0 is usually called that it is indeterminate form, or in other words we just say that it is undefined. So if 0 over 0 form is indeterminate or undefined form, so this means that both of the sides are not equal, and if both of the sides are not equal, this concludes about that the value of h is equals to 0 is not satisfied our given question statement. So we conclude about that h equals to 0 be the extraneous root of the given equation. Okay, this is the extraneous root because it does not satisfy our given question statement. And now we move towards our second root, and this is our second root, and we substitute this value of h on both of the sides, and it will be written as 1 divided by 1 is equals to 1, and you clearly see here 1 equals to 1. This shows that both of the sides are equal. It means that the value of h is equals to 1 is satisfied our given question statement. And finally we have the solution set of this problem is h equals to 1. So this is the only one solution, and h equals to 0 be the extraneous root, and this is the final answer which we get here from first method. And now we again solve this problem for a second method. And for second method, we need to copy down given question statement. Here it is h divided by h is equals to h, and this is our given question statement. And here we use the nice exponential law to solve this problem, and you know about that if we have a to the power of m divided by a to the power of n is equals to a to the power of m minus n. So we move the exponent from numerator towards the from denominator towards numerator, and it will be written as in this form. And you see here in the left hand side the exponent of both of these two terms are 1, so we move the exponent from denominator to the numerator, and it will be written as h to the power of 1 minus 1 is equals to h. And here you see that 1 minus 1 becomes here 0, and we get h to the power of 0 is equals to 1. And here we know about that any number whose exponent is 0 is always equals to 1. So h to the power of 0 is equals to 1. And when we substitute it here, and we get the value of h is equals to 1. So this is only one value of h which we get here from second method, and in the first method we already verified that this value of h is satisfied our given question statement. And finally we have the solution set of this problem is h is equals to 1. So this is the only one solution of this problem, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.